Oh. Well, that would be a reasonable formula. I'm not sure whether. Let me finish the thought here. Not at all a. I mean, that's a reasonable thing to suggest. I wonder, does that actually define?
Does x acting on b give you b again?
Does that give you an fx module? What would we need? We need it to obey, you know, the axioms of the module actions, right? So we're mostly worried about A, B, C, D. It is commutative, so D applies. So like the identity polynomial maps to, yeah, axiom D is okay.
And then you get, and then I think 3 is okay. No, wait, let's start with 1. So R plus S, which is an R acting on M. So
Yeah, I mean,
V1, V2, essentially.
yeah, I think that's going to be okay, because if you have polynomials, you just add coefficients of like terms, or you keep unlike terms.
Yeah.
And so I think the axiom, my gut reaction is axiom A is okay. Axiom B might get, maybe B is where it goes wrong. Maybe? I don't know.
Take 2 polynomials.
I'll keep it relatively simple. So like
No.
A,
Axiom B should be all right.
A plus BX,
Yeah.
C plus DX is AC plus B, BC plus AD,
Yeah.
X plus BD, that's supposed to be an X, BD X squared.
Yeah.
So this acting on V for you would give me AC plus BC plus AD plus BD, all acting on V, compared to, let's see here, we're supposed to let A plus BX act on this acting on V, which would be CV plus DV, which would give me ACV plus DV plus BCV plus DV, which gives me AC, AD, BC. Yeah, it's the same bloody thing. Yeah, you're right. So, I mean, that's only checking the binomial case, but it'll work. So, yeah, it looks like axiom B is okay, and axiom C, I'm pretty sure is fine. Dang it, you found another module action.
My bad.
How dare you. Jerk. No, okay, so the thing that makes this module action, so the module action that I was fishing for is intricately linked to T. So as you can see, I mean, this is fine, but this does not tell me anything about the, actually, I think this, what you just did, is the module action in the case T equals to the, I think what we're going to see is this is actually the T equals to the identity case of what I'm about to write. Oh, cool. Cool. Check it out, yo. You checking it? All right, very good. There I go. Oh, yep. So what I was fishing for was this, A0V plus A1TV plus plus AN T to the N V. So, or you could rewrite it like this. This is A0 plus A1T plus plus AN T to the N, all of that acting on V, because you can add linear operators, right? You can add linear operators,
Yep.
And that's the definition of addition, basically pointwise. And so another way to write this action is simply as follows. F of x acting on V is equal to f of t acting on V. And so yeah, see, when you have the identity, when t is the identity,
Yeah.
those are all just V. That drops back to your action. Neat. Okay, great. Now, so this defines, in fact, a submodule, an FX submodule on V. Now, we have things to check for that, right? So, but basically, all of those things follow from polynomial algebra.
Yeah.
So, for example, you know, we have one of the things we're supposed to check for, like, axiom, what was it? Let me just talk about B. I think B is kind of the most technical one. RSM. RSM. So here that would look something like f of x, g of x, right? Acting on V, right? So my m is V, my r is f of x, my s is g of x, right?
Yeah, but I mean, you can just write them both as generic polynomials and just like a naught.
Right. So this, right?
Yeah.
So versus r SM,
Yeah.
which is f of x acting on g of x acting on V, right? So that is f of x acting on g of t acting on V, which is, of course, f of t operating on g of t of V. But the definition of operator multiplication is composition. So like this is literally f of t, g of t. This is definition of operator multiplication. And this is exactly equal to that. So, I don't know. We could talk more about why this is true, but in the time that remains, I just want to talk to you a little bit about what is a submodule here. You know, what is a submodule of this module? So suspend your disbelief that this is a module for us, an FX module for a second here. I know you got to go, so what is W a subset of V, which is a FX submodule? So it's not just any old subspace of V, right? It has to be a subspace of V, which is what? Which is fixed under the FX. So we need something like f of x times W is equal to, you know, f of t acting on W. We need that to be an element of W again, right? For all polynomials in the ring, right? In W in the subspace. Little w and the big W. Lemma. Well, I guess observation, maybe, I don't know. So if we had, so let's see here. First of all, if I have a constant, right, times W, that is definitely an element of W again, since W subspace. So I'm assuming W is a subspace. I'm trying to figure out what kind of subspaces are FX modules, right? So whatever happens with constants, not a problem, right? But if I have something like X acting on W, well, that's what? That's T acting on W, right? We need that as an element of W again. Time to go?
I think so.
So in short, in short, T of W has to be an element of W from that, right? But the cool thing is, actually T of W, an element of W, right, implies that T squared of W, which is T of TW, well, so if T of W is an element, if T of W is an element of W for all W, right? If this is true for all W, then certainly if T of W is again in W, then T of TW is again in W. So like, in fact, an arbitrary power of T.
Oh, yeah.
And as a consequence, then, if I look at f of T, right, any polynomial in T acting on W, the constants for free. So if we know that T of W goes back to W again, well then T squared, T cubed, T to the n of W is again back in W. So it suffices to know that W is a fixed subspace of T. So basically the condition is that T of W, subset of W. This is the condition that is needed for W to be a fx submodule. So this module action tells us information about the linear transformation T. See, we're trading a statement about a linear operator for a statement about a corresponding module. So we can study the structure of the linear operator by instead studying the structure of the module. That's the trade. It's not at all obvious why that's helpful at the moment, but we'll see that it is. I think. Anyway, go run! Woohoo!
Yeah.
Run away!
My coach
Run away,
says-
you coward!
Oh, I'm running away. Even though-
Sorry.
Enough, my mom did yell at me yesterday because my concealed carry license came in the mail.
Oh yeah.